Today we're going to be doing a different type of agentic coding test, one that combines software development with physical interactive hardware. Using Opencode and the newly released GLM-4.7 Flash running locally on a DGX Spark, we're going to see if this small local model can build a 3D game designed specifically for a custom desktop arcade cabinet. For today's video, we're going to be doing some agentic vibe coding with the newly released GLM-4.7 Flash. Now, this is a very popular model, and I have to say, I'm looking here at the unsloth quantizations of this model, which we will be using one of for today's task. But the amount of downloads that have already been shown here, which are inevitably delayed a slight bit, really reflects the large amount of popularity in this model and does highlight the fact that a model of this size that is specifically focused on agentic coding, or at least strong at that task, is very, very much wanted and well received by the community. So this is just really cool to see. In terms of the specific setup for today's testing, we're going to be using the Q8KXL quantization of this model, this specific unsloth GGUF, running on the DGX Spark with a context length set to 64K. Now, the context length for this model can go much higher than that, but there currently appears to be a bug with having flash attention working on that specific machine with the specific setup that would run this through Llama CPP server, and due to that, I have to keep the context length around there or else it starts to get extremely slow. In addition to that, prior to, I think earlier today, this model was actually not properly implemented into Llama CPP, so if you had tried this previously and were noticing you had issues with looped outputs or something just not working properly, it is very likely that that was the root cause of that, and if you go ahead and re-download these GGUFs and update Llama CPP, you probably will be all set to get significantly improved output. So just as a mention for anyone who may have initially tried this and thought, oh, this does not work as well as I would have figured. Beside that, we're going to be using this through Opencode. Now, personally, I don't have a lot of experience in using Opencode, and the reason I'm opting to test this is because a lot of folks in the comments for my initial test video of GLM 4.7 Flash had mentioned that Opencode would be a fantastic pairing for this model. So being that that is the case, I'm happy to try it with Opencode. Now, for the exciting part, at least in terms of my interest, the whole point of today's project is essentially going to be vibe coding a game to run specifically on the arcade cabinet that you may be able to see behind me. This is something I actually designed and created specifically to test models in creating mostly games for a specific piece of hardware. While this is software related, where they do have to ultimately make a game, there's a lot more thoughtfulness that must go into specifically crafting it for this arcade machine because of some of the ways that it's actually designed and set up. So starting off, we can just kind of take a quick tour of this device. It has a joystick and two arcade buttons that are from a retro emulation hardware kit, which are just seen as one input to the host system, which in this case is the cheapest gaming laptop I could find at Micro Center that I did just kind of cannibalize to build this arcade machine. I don't know, I figured it was a good use of money. And then in addition to that, there's a steering wheel and a blinker stalk. The steering wheel is connected to a potentiometer to basically take steering input reads, and the blinker stalk is connected to a little 4-pin push button switch. Both of those are connected to a Raspberry Pi Pico, which acts as an HID device that is also plugged into the host system. And the models are going to have to eloquently craft their game result in properly implementing these controls. I didn't really design this with the intention of trying significantly smaller models such as this, so this may be a task that is outside of the scope of this model's capabilities. However, it performed so decently in my initial testing of it that I do feel somewhat comfortable in actually letting it loose and trying to create a functional result for this arcade cabinet. Being that it is local and everything like that is also exciting. So we can see right here that I have a terminal window open, and this terminal window is just SH staged into the arcade cabinet behind us. So everything we see done right here on this screen is happening on this machine right here, including what we're about to do, which is start Opencode. Actually, prior to starting Opencode, I do just quickly want to show two of the files, the only two files contained in the specific repository that we're going to let our agent loose in. One of these is the game spec markdown, which is essentially just giving the agent instructions on the end goal or what we're having it create, with some additional information about the specific control inputs as well. So for a TLDR of this prompt, it's basically create a single file HTML5 3D driving game for this custom arcade cabinet, and then we get a bit of additional information here for how to actually map the controls and things of that sort. The only other thing inside this repository is the control map.html file, which we can take a quick look at right here. And this file is just a very simple 2D canvas that highlights how these controls work properly. So if we were to run this on the host system or the arcade back there, we would see a little green box that can actually be controlled by pressing the joystick forward and backwards and then turning the steering wheel left and right. So this is just designed to give the agent the understanding of what the proper implementation of these controls looks like. With that, we're now ready to just go ahead and type Opencode, where I do have GLM-4.7 Flash already hooked up and communicating with the DGX Spark where it is running locally. Now, while I'm not super well versed in Opencode, I have played with it a bit in just trying to fine tune the balance between context length being long enough for this task and not being so large that it just slows to a crawl in terms of token speed, which is why I landed around 64K. And based on the documentation, the first thing we are to do here, being that Opencode is opened in our specific working repository for this game, is just to type init, which will allow us to have the agent go in, look through this repository, see if there is currently an agent's markdown file, and if there is not, it will generate one based off of its findings in this specific repository. And we can see right here that these are all chain of thoughts, or everything here is contained within the chain of thought of this model, as it is a thinking model. And we can see right now that it is properly performing the specific actions it must, such as searching the repository. And a lot of what it does here is designed basically to find things in existing larger code bases or repositories, things that are not specifically contained in this, being that this is a very light and starter repository. And we can see the speed here is not bad at all. Again, this is the largest of the Q8 quantizations from the unsloth GGUFs, and it's working at a very reasonable speed in my opinion. The current task that it's performing right here is just the agent's markdown file, which it is going to create, and I do believe based on the initial prompt it says it should keep it around 150 lines or something of the sort, around 150 lines long right there. And we can see that we probably did see while it was going ahead and generating, but it just has an understanding of the code base, and it was able to read and find both of the files contained within this repo, which are obviously very light considering this is a brand new repository and not something that is really an existing code base. And we can see relatively quickly this has created the agent's markdown file, which we can see right here. And I won't verbosely read through this, but I will make sure that it stays on screen long enough for anyone interested in seeing everything it wrote here to pause and be able to do so. And it has understood that the game is currently a 2D prototype, which is really just that very simple green blob driving around on screen, just to understand how the controls work for this, as I don't want to leave that up to the model, especially one of this size. It would probably just detract from the experience of seeing how well it performs here. In addition to that, it has just told itself, okay, here's the JavaScript style, here's the HTML structure, naming conventions, formatting, input, output, which is very important so the controls do properly work, error handling, code comments, and hardware integration, which we can see it is properly referencing things from the controller map.html file, which was, again, that little green thing that drove around the screen, and future considerations for moving to 3D. Very good. And part of this prompt is also going to have it. The whole goal here is essentially a free roam city driving game, starting out with just procedurally generating around 200 buildings, which are only going to be cubes of varying sizes and heights, just to give us some semblance of a small low poly city. And now that our agents.md has been created, the next step, and what I probably normally would do if I weren't doing a video and wanted to do some due diligence and proper methodology, would just be to tell it, okay, go ahead and build it. However, because I want to explore more of the capabilities here as well of Opencode, I have just pressed tab to swap over to the plan mode, which we can see in the bottom left. We were in the build mode, but when we press tab, it goes to plan. And I'm going to say, please craft an implementation plan for this project. And again, that is kind of the agent's markdown file is almost like what it just did when I'm asking it for this, but because I want to see how it performs in these different modes as well, I'm okay with doing this. It's already read control map and game spec, so it has a good understanding of, and then it is listing things. And again, the speed is really not bad here at all, running on the DGX Spark with the 64K context length. Now this is interesting where it seems to have encountered some issue where it was trying to create the implementation plan.markdown, but for some reason it seems to have run into a permission issue of sorts, which I have not actually seen in playing with this at all prior, so this is a little frustrating just because it will eat up some of our context length. I don't want to stop it right now, but it should be able to create files in the working directory that we're in. That makes sense. So I've actually made some level of a mistake here as well, because we see right now, and this is good to see, I'm actually happy this happened because it shows the model is properly understanding some of the rule sets that are ascribed to it in either of these specific modes. So it says it can't make any edits, modifications, or system changes, so it is disallowed from doing so within this plan mode. So all we should have hoped for here was actually just seeing it showing us the plan here, but not creating a specific file. And again, when it comes to vibe coding, agentic coding, whatever, everybody is going to have a specific opinion on the best way to interact with the models and things like that. So what I'm writing here is just talking to it in natural language, as a lot of folks, especially beginners, will very likely be doing. And I'm happy to see that this is ultimately what we would have wanted to receive in this plan mode, where instead of trying to create any files or do anything like that, it is just telling us how it specifically plans to go around creating this game. And we can take a peek and see right here. So, okay, it is creating the car model, or just outlining its plan to do so. And in some of the game spec markdown file, which we briefly had looked at, which was an existing file in this repository, when we started, we did tell it to just lock the camera in front of a rectangle so it makes it look like the user is looking out over the hood of the car. And the beginning of this is very simple. We're mostly focused on actual functionality, in that the controls do properly respond and you can quote unquote drive around the little city. If it does work properly, then we can maybe push this a little more in implementing some detail enhancements and things of the sort. So, car style preference, environment layout, target resolution, or color palette preferences. I had not intended to send that. But this is actually good to see because, okay, it understood that I answered question 1, and now it still needs to know questions 2, 3, and 4. And I've just answered all of the remaining questions here, saying make it grid, streets, and organization. So that's actually cool because the initial game spec did not really denote having any streets. It just said make a bunch of random cubes to look like buildings. So it'll be interesting to see if it puts any mesh colliders on those, meaning that the car can't just drive through the buildings. I would guess that on first try it likely won't, so we will be able to drive through buildings, but it will be interesting, and that can be an additional improvement. And we can see right here that this is just still in plan mode and giving us this final implementation plan. All right, and we can see right here it has culminated with an estimated timeline, which is likely a bit longer than this will take, hopefully. This plan is ready for implementation when you exit plan mode, which we will do now by hitting the tab key. And now we're back into build mode, and I will just say implement the plan and build the project. Now this will inevitably take a decent bit of time, so I'll probably end up just time-lapsing this as it does go on, and I'm really quite eager, as I have not played anything on this arcade cabinet yet because nothing's actually been designed for it, aside from very simple test scripts to make sure the controls work like what we saw with that little green box. And in really not too much time, we see that a 277 line script has been produced right here, and it's saying perfect, and this is the chain of thought. I've created the complete 3D driving game with all of the components from the implementation plan. I will be very interested to see how this works on first try. As I may have said in the beginning of this video, this was a test I was going to have for Claude, Opus 4.5, Codex 5.2, or Google's Anti-Gravity with Gemini 3 Pro. Even Gemini 3 Flash would probably knock this out pretty well. This model is significantly smaller than all of those, and it is quantized. This is a Q8 quantization, which again probably should still perform relatively decently, but it's just neat to see how this performs agentically. And again, it goes back to, I think, the raw amount of downloads that were shown in even the unsloth quants for this model just really highlights the popularity of a coding model of this size that is somewhat competent at agentic coding and producing running code. So this is very interesting. It's giving us what's been built right here, and we can see all of these phases. It is just regurgitating these specific basically like checkpoints that it did implement for each of these phases, which I do like seeing. And I find it funny now that it had estimated this would take like 8 to 12 hours. And in reality, I think this took like 5 minutes. All right, in 6 minutes and 19 seconds, we hypothetically have a functional result, which I will now need to hop over to the arcade machine to actually test. All right, so as soon as I press this button right here, we should get our first look at this game. Okay, I see some rectangles. Let me try this. So sadly, we see that nothing actually worked at all. I wasn't 100% positive that it would be a perfect looking 3D result at first, which is to be expected, but sadly the debug overlay did not show that any of the controls were being read properly, which is a little frustrating being that we did give it a specific implementation reference for the controls to make them work properly. So now the next step is going to be to I think I would swap it back to the plan mode here just to ask it or give it some feedback about what went wrong without allowing it to immediately jump in and try to make changes. And I'm telling it what's gone wrong here, which is we just get a gray box within a gray box, but more importantly, none of the controls are actually being read by the system. The sample control map HTML in the project directory does work properly, so what specifically is incorrect with this result? And I'm happy to see that it seems to be prioritizing the issue that I'd said is more important, which is the fact that the controls just are not working at all. If we can knock those out first and foremost, at least so the debug panel is actually showing when they're pressed, it should be much simpler to then go ahead and troubleshoot some of the 3D object issues. Okay, it says it's identified the issue and it's preparing a plan to fix them, but a lot of what it's showing here is more in line with the graphical anomalies we saw where basically none of the graphics were properly working, and less so with the controls actually functioning. I'm going to just let it run through and see what it says here, and once it has concluded in listing the specific problems it's found and what should fix them, we'll just swap over to build mode and have it implement these fixes. Now, it didn't necessarily specifically reference the controls not working, but perhaps the camera fix will also control that because they say update debug values to use a separate camera reference. So perhaps since the debug values were supposed to just show us when the controls are being pressed, maybe it thinks that will fix it. And I'm just going to now tell it to generate the complete updated corrected file. And this will inevitably take a little bit of time. So in 14 minutes and 26 seconds, we did receive what is hypothetically an updated and fixed version of the script. We will basically just now go ahead and test it before we really pay too much attention to anything created here, but it does show us the specific things that it has fixed that it did initially identify in plan mode as causing the issues we described. So I'll leave this up, but time to test. All right. It actually, can we steer? Oh my God, we can. It did. This is actually, all right, I'm impressed. Wow. I'm seriously impressed. Now, the whole reason we had that little rectangle there is because it must have just made this like 800 by 600, which we can ask it to change. It did create a grid-like city. There are definitely some critiques that one could give it, but this did this. And again, this is more than just making a simple little web game. It had to use our reference for making these controls properly mapped to it, which they absolutely do. And we can see right here that it's actually tilting the car when we turn the steering wheel. The controls do seem inverted, at least the steering is inverted, but that's a simple fix. And really, I think the thing to do now is actually continue to vibe code this because we have a working prototype, which is awesome. Wow. I've swapped back into plan mode here, and I now feel comfortable in giving it some additional detail that I would like implemented in this game. Mainly fix the inverted steering direction, which is not a big deal. The streets are a bit too narrow and cluttered with buildings, so I would like the map to feel just scaled up a bit larger, with perhaps less buildings and wider streets. In addition to that, I want the sky to not be pitch black, but a light blue, and the resolution should be changed to be 1920 by 1080 to match the natural resolution of the display that this game's being played on. And we are in plan mode right now, and this is just, I mean, I like this. I'm excited. I'm going to play it a little more because it's just so neat. And this is a local model that is capable of being run on a lot of consumer hardware. Maybe not the Q8 Quant, and I have not specifically tested the degradation in performance one would experience when dropping down to like a Q4KM or something, but still, this bodes very, very well for a model of this size. The plan mode is coming to a conclusion here where it's just giving us this interesting table of its summary of proposed changes, which is everything that I'd asked it to do. Fix the steering, make the map a little less cluttered, change the skybox color to be a light blue, and also just fix the steering. I don't remember if I said that one already or not. So we should be ready to swap over to build mode very soon and then have it implement these changes as well. Oh, and change the resolution to be the native resolution for that display so we don't see it in that tiny little window, which does give it a retro aesthetic, but I'd rather see it in full size. And we've now told it to implement the changes, which will take a little bit of time. So these changes only took around 13.5 minutes, and I suppose that makes sense being that none of them were very complicated, so now it's time to hop over to the arcade machine and see how it looks. Which, I can probably just reload the file here. Spot on. Alright. Alright. Whoops. Uh-oh. I had put a tiny limiting peg in the back of the steering wheel to make sure that it didn't spin too far so the pot didn't get broken, and I just snapped it off because I got too enthusiastic about playing this game. But overall, this worked really quite well. I don't know specifically what to do now. I almost want to just restart this agent from what we have now and ask for a few other changes, but really, I mean, this definitely exceeds the expectations of what I assumed we would get today. I'm quite pleased with the performance of this model right now. And I think that's probably going to conclude today's video, which was just seeing how far we could push this model in some agentic coding. I have to say it definitely lives up to how it was performing in the test video I did of it originally, where I was not running it locally. In that video, we were just using the ZAI API, so I'm very happy to see this performing quite well at a Q8 quantization on a local system, as this is going to be a model that a lot of folks are likely very interested in seeing how well it performs, and being that the Llama CPP implementation is now fixed, a lot of folks can just download this locally and start playing with it, and I think you're going to be quite pleased with its performance to size ratio. I know personally I very much am, and I almost want to use what it made today as a basis for a repository for different models to then go ahead and improve. Instead of just starting out with a very simple empty repo like we did with this, I almost would like to use what it created as a building block to create a more feature-packed game, if you will. So that's going to conclude today's video. I'm very excited by this model. It was truthfully a lot of fun to not only see it create this game, but to actually play it. Hopefully that's somewhat conveyed throughout just seeing it in screen recording as well. And that's going to wrap it up. So if you have any questions, please feel free to leave them in the comments, and thanks for watching.